Right, okay, so the first thing we always need to do is make sure we write all the nodes down. So on purpose, I haven't just done an alphabetical list to make you think. So we got A, doesn't matter what order you write them down in, B, X, P, Y, and Z. Right, the costings, the start node doesn't cost us anything to get to the start because that's where we're starting. So we always put that in 0. And then for Dijkstra, remember, all of them go in as infinity, the rest of them. Or whatever weird symbol you put for infinity. Try and make it look a little bit like infinity. Okay. And then the process, remember, just the basic process. Find the lowest cost that's still accessible. So not in the closed set. Look at its neighbours. Work out how much it costs to get to those neighbours. If that cost is better than the cost we've already got for that neighbour, update and put the parent down. Keep doing that until you go and visit the goal. And hopefully, if you can't visit the goal, that means there's a break. So if I could have, if I'd have stupidly put like a direction on the ZP one, so it went Z to P, you go, oh, I can't get to Z. I'll do that. I'll do that afterwards, and we'll see what that looks like. Right, okay, so I'm just going to pick the cheapest cost. Parent for A is obviously null, so I'm going to put that in, no parent. Right, so pick the cheapest, it's A, obviously. First job I do is close off. Now, I've got actually a node called X here, so I'm going to use an asterisk as my marker for it being closed, just so I don't confuse myself. Right, my neighbours. So I've got a node B, but that's a direction that I can't travel in, so that doesn't act as a neighbour. The only other node that's connected is X, and it's going to cost me 2. 2 is better than infinity, so I'm going to update my cost, and I'm going to say, right, that was travelling from, and I've gone and done a stupid thing. Yes, Richard. Oh, have I still frozen it? Oh, okay. Doesn't matter. There you go. Right. I stupidly wrote it down on B because it was the next one down. So be very careful. I wanted X. So it's X that I'm updating with a 2 and put the parent down when you update. Okay, so I'm going to go round the process again. Pick the cheapest. The cheapest available is going to be X because that was a 2. So I mark it straight away as closed so I don't visit it again. Right, it's going to cost me 1 to get to Y, but it isn't just 1, it's how much it costs me to get to X. So the total cost there is going to be 3. And that was traveling from X. X hasn't got any other neighbors, so we've finished that loop. And this is the loop, and that is the Dijkstra loop, and we're just going to keep going. So we're going to pick the next one, pick Y, close it off straight away. It has got one actual neighbor, and that is P. Okay, so it's going to cost me 4 to get to P. It's already cost me 3, so that's going to cost me 7, but that is better than infinity, so I'm updating. And that was from Y. Okay, I'm going to go around again and pick, and you can see that P is going to get picked this time. Close it off straight away. So it's cost me 7 already to get to P. It's got a neighbor B. So that will be 10 plus 7, 17. That's better than infinity, so let's update that. And that was traveling from P. It's got a neighbor Z, which is 8 additional cost. So that's 7 plus 8, which is 15. That's better than infinity. So we're going to pick that, and we're going to say P. No more neighbors. Okay. Don't look at Y because it's not a neighbor because of the direction. Okay, so we're going to go around the loop again, pick the cheapest. This time it is Z. So close it off. That's the goal. So we can stop. So at that point, we've found where we were trying to get to. So we're going to then trace the route back. So we're going to say, right, we arrived at Z, but where did Z come from? So we look at the parent, and that was P. Where did P come from? So we look at the P, and that was Y. Where did Y come? Which is why we call it a parent, because where did that come from? So where did Y come from? And that was X. Where did X come from? X was A. And that is our root. So we're going to make it clear to the examiner that that is the root. I'm not going to put the root in a random location. That's super important. Okay. Right, let's do it so that the Z is one way. So we can go Z to P. So let's just update the graph. I'm going to go through the same process. I'll do it a little bit quicker. Let's see if I can. Oh, it'd be quicker to just rub that all up. So if I just get rid of those and put them all back in the open set. I'm just going to start again. Put all my infinities in. Just to see what happens when we can't make the root. I've not seen a question that was like that, but it'd be a good question to give you. Right, so we're going to pick A. A's got a neighbour X, which costs 2. So update that to A. Close it off. Right, going around again. X is the one that we're going to pick, so close it off. It's got a neighbour Y, which costs a further 1, so that's 3. So that's obviously that's identical to what we've just been doing. So that was the parent X. Go around the loop again. We're going to pick Y this time, so close it off. Y's got a neighbour P, which costs 4 additional, so that's 7 in total. Go around the loop again, and we're going to pick P. Right, so P has only got one neighbour this time, B, which is going to cost me 17. That was from P. Go around the loop again, we're going to pick B. And then 17. So it's cost me 17. It's got a neighbour A. Right, neighbour's got a cost of 0, so we're not going to beat that. So there's no point in updating that. That'd be a funny route to get to A. Okay, now, in this case, we have now got one item in the open set, but its value is infinity. Okay, so if we was to pick that, and we looked at the neighbour, so if we pick that, we go, hey, we got to the goal. But look what happens. So where we had that route there, we could say, hey, we got to Z. And we go, Z came from A, no parent. So even though we picked it, it's infinity, it's the biggest number there is, but it was the only number that was left in the set. So we go, and that shows you cannot get to Z. All right, so you might get a system like that. So just be aware of it.